Every time you turn on a light, charge your phone, or power your laptop. Have you ever wondered where that electricity actually comes from? What if I told you, a big part of it starts with burning coal to boil water? Electricity is one of the most important forms of energy in our lives. It can travel hundreds of kilometers and power everything from homes to entire cities. Behind all of this are massive facilities called thermal power plants, machines built to convert heat into electricity. At first glance, a thermal power plant might seem complicated. But the core idea is surprisingly simple. Burn fuel, create steam, spin a turbine, generate electricity. That's it. Everything else is just making this process efficient and continuous. Let's follow the journey of a single drop of water to see how it magically transforms into the electricity powering your screen right now. Step 1. Fuel supply. Every great cup of tea needs heat, and our giant power plant kettle is no different. It all starts with fuel, usually coal. Huge amounts of coal are delivered to the power plant. Before burning, the coal is crushed into fine powder. Why? Because smaller particles burn faster and more efficiently. In fact, a large power plant can burn over 1,000 tons of coal every hour. The goal here is simple: create an intense, continuous inferno. Step 2. Furnace and boiler. The crushed coal is fed into a giant furnace and burned at extremely high temperatures. Burning coal produces waste gases and ash. Modern power plants clean these gases using special systems to reduce pollution. Even the ash is often recycled, for example, used to make construction materials like concrete blocks. Inside the boiler, water flows through tubes and gets heated to over 500 degrees Celsius. At this point, it becomes superheated steam, very hot, high-pressure steam. This steam holds a huge amount of energy. And now, it's ready to do some work. Step 3. Turbine. Now, we have to harness all that angry, fast-moving steam. The steam is directed toward a turbine. It looks like a giant jet engine filled with thousands of metal blades. As the high-pressure steam hits the blades, it spins them rapidly. This spinning motion is powerful, and it's the key step where heat energy becomes mechanical energy. Step 4. Generator. Here is where the real magic happens. The spinning turbine is connected by a giant metal shaft to a generator. As the turbine spins, it turns the generator's rotor at high speed, thousands of rotations per minute. Inside the generator, this motion creates electricity using electromagnetic induction. The result? A steady flow of electrical energy. Step 5. Electricity transmission. But we're not done yet. The electricity produced is increased to a very high voltage using a transformer. Why increase the voltage? Because it allows electricity to travel long distances with minimal energy loss. Then, it flows through power lines, all the way to your home. Step 6. Cooling and reuse. After spinning the turbine, the steam is no longer useful. So it's cooled down in a condenser and turned back into water. This water is reused again and again in a closed loop. You might have seen large cooling towers, those structures releasing white clouds into the sky. That's part of the cooling process, where excess heat is released. So, there you have it. Fire boils water, water makes steam, steam spins a giant pinwheel, and the pinwheel spins magnets to make electricity. The next time you turn on a light, take a second to appreciate the raging fires, the roaring steam, and the giant spinning magnets working tirelessly miles away just to brighten your day. Thanks for watching. Hit that subscribe button for more science stories, and let us know in the comments what you want us to explain next.